All right, so welcome everybody. So I will be talking about our experiences building a social city builder game, and especially doing so on a fairly small budget and a team. So my name is Petri Kero. I'm one of the co-founders, the CTO, and as it happens, pretty much the whole backend team of Ministry of Games. So Trade Town, this is basically our latest game. It just went live on Monday into some technical testing. So if you happen to be in the Philippines or in Finland on Android, you can find it in the App Store under the beta section. Just to tell a little bit about the history of this game, how it came to be, it basically all started from this question of like, what if somebody made this really old classic from the 90s called The Settlers into a mobile game and today. And what that means a little bit in practice, Settlers was always a city builder game and a kind of crafting-based resource management game. So we tried to stay true to that. But then at the same time, we had already been a little bit burnt by a previous project where we, I think, innovated maybe a little bit too much, and it wasn't that great of a success. So we also wanted to get a fairly kind of proven core. But as it happens, there's a bunch of games like Heyday and SimCity Build It that have a really nice, engaging inner loop, which then allowed us to kind of take a lot of inspiration from those games, make a unique mix of our own. But then on top of that, let us innovate more on the outer loops, and especially so on the social side of things. So there we actually took a lot of cues from games like Game of War, so these MMO strategies where people really like kind of go into guilds and cooperate into guilds, coordinate with each other and try to achieve common goals. So this is pretty much the kind of project vision that we set out to do, and I think what we kind of delivered on fairly well as well. If you look at this from the backend's point of view, there's a couple of these really like kind of big issue items that we needed to tackle. One is that there's this single persistent world. So any action that you do in the game basically changes the kind of state of this whole world. And essentially every single action is also potentially observable by somebody else. And we wanted all of that stuff to happen in real time. So no matter if you start producing stuff or if you hang out in the guild and chat with your friends, we wanted everything to kind of also happen instantly. And these put a lot of pressure on how you can actually manufacture or how you need to build the backend services. And then looking at from the kind of game feature point of view, we have a lot of social features in the game. So it's both in frequency, so a lot of stuff happen all the time in social, so player-to-player interactions, but also we have a huge variety of different social actions. So we have multiple types of helping. You can visit other people, there's chat, there's all kinds of interesting stuff like guild buffs and so forth. So we're really trying to push the envelope on the social features. And maybe as the kind of crown jewel of the game is this guild versus guild competition and these weekly events that we do called expeditions. In each one, it basically lasts a week, and we really wanted to capture this like kind of combat style way of playing from Game of War, but in a peaceful setting, so that it's more a points race, very much inspired by kind of classical board games as opposed to combat. And then last but not least is this player-to-player trading. So anybody in the game can put items on sale into the global economy, and anybody else can basically see them. Very similar to Heyday's or SimCity's trading, except that, again, it's happening in real time. So instead of the state being refreshed every minute or so, we actually push in real time, every couple of seconds, new sales to all the players who happen to be online. And then some more technical requirements. So in order for a mobile game to be successful, you need to be able to support a lot of players, tens of thousands concurrent at the minimum, basically. And obviously in every backend engineer's wet dreams, you kind of imagine the case where you have the 5 or so million concurrents that the top games on the market have. Also, you really don't want to be down, the servers to be down. It's a really big bummer for the players. So the stuff needs to be kind of resilient to failure. And you cannot really let the budget also run out of hand, so you have to be a bit careful how many computers you rent and how much database accesses you're doing. And then this is kind of particular to us, but we also wanted to make this with just one-man team. So sounds fairly ambitious. So how would you actually go about doing that? Turns out the plan is not that super complicated. So what we did is to identify the pieces that we really needed to build ourselves and stuff that you cannot really buy from the market, and then basically just buy everything else as a service or otherwise. And it turns out that there really wasn't, at least at the time, any middleware for doing such a kind of complicated backend. So that was something we needed to build ourselves. But everything else we basically bought from somebody else or buy as a service. So this includes obviously being in the cloud in the first place. You get all your load balancers, computer rentals, and that sort of stuff. But also there's a huge amount of kind of in the services that you can buy, like logging and analytics and metrics and whatnot. And maybe as one kind of interesting case that has happened fairly recently is that you can buy basically buy databases that are infinitely scalable and start at very reasonable prices. So both Amazon and Google have their own like NoSQL database that you can just access, and these are typically one of the more kind of tricky ones to maintain. And in our case, we really did not want to be spending a whole lot of time on kind of operating the machinery, but rather spend as much time developing the game itself, so adding new features and making the game better. And then to kind of bridge these two worlds, you still have to run your game server that you made somewhere. So there's nowadays these like new tools called containers and orchestration of them that we are heavily using nowadays. So those really help us deploy the servers into the cloud reasonably and efficiently. So I'm not going to go too deep into the actual game server itself. I gave a talk about it, more detailed talk about that in this year's Elixir conference. So if you're interested, do look it up, or you can come talk to me. I really love talking about this stuff to the end of the world. But just to highlight a couple of key features. So everything in the servers is basically stateful. So we keep all the hot state, all the player states, all the guild states, everything that we need to run the game in memory all the time. So we basically use database as just this kind of backing store where we, if something is inactive for a long enough time, we just kind of serialize it down there and then bring it back when we need it again. And this allows us to do very complicated operations because those objects can be smart and they can communicate with other objects and so forth. Another interesting thing is that all the clients, while you're playing the game, they stay connected all the time. This basically allows us to do real-time stuff so that when something happens on the server that the client needs to know about, we can immediately send them a message as opposed to waiting for maybe the next poll cycle to happen. And this really gives us the ability to do stuff in like order of a couple of 100 milliseconds from when you do send a chat message for me to actually see it in game. And also the servers, they're fully distributed, so we can run them on one machine or we can run them on 20 machines. And to the outside world, it pretty much looks like there's just a single box in there doing the stuff. So we don't do any arbitrary bucketing of, these players stay on these servers and those players stay on that server, and they cannot really talk. Not what we do. Everybody is kind of in the same bucket, and everybody can connect to everybody else. One of the ways why we were even able to do this with such a small team, I think, is because of this new programming language called Elixir. Its roots go back all the way to like the telecom industry in the 70s. There's this language called Erlang, or Ericsson language, I guess short for, that they used to build basically these telecoms boxes for, and they really were valuing like high availability and so forth. And Elixir basically compiles down into the same virtual machine. So you get all the power of that like kind of decades-old battle-tested infrastructure. But obviously as a downside of kind of being invented in the 70s, the Erlang language itself is fairly archaic. So Elixir kind of modernizes all of that and makes using it and onboarding into it very easy. Just some of the highlights. of the language, so it's a functional language, meaning that you can get a lot done in a very short amount of time. It does a very good job at distribution and clustering, meaning again that you can scale and do all this real-time social stuff without spending a huge amount of time building your own communication layers and so forth. It is fault tolerant, so this may be the most interesting thing about the whole Erlang ecosystem, and maybe unique thing about it. I won't go into too much detail about it, but it really allows us to, in practice, kind of keep our servers up, even when there's trouble happening. Most often the particular failures, they're isolated, so that if, with some players, logic or state, there's some kind of problem, maybe that player is not able to play the game for a while, and then until somebody fixes that game, but almost never it propagates to elsewhere. The virtual machine is fully or natively actor-based, meaning that every actor or player state or so forth has their own heap, meaning that there are no these like long stop-the-world garbage collection pauses that tend to happen with many other languages, like, I don't know, Java, for instance. So we don't need to worry about that at all. And then it can do stateful stuff very easily, so we can keep the player states in memory. It's very, very natural for that system, and that allows us to not go into database almost ever. So we only periodically basically save the player states there, just to make sure that if things crash, that we don't lose a lot of state, or maybe if somebody has done something like an in-app purchase, we serialize that into the database so that we don't lose it. And there's been like I think this like ecosystem is being rediscovered in the past years. So for instance, there's really nice success stories like WhatsApp being done lately. I think they use Erlang. There's Discord using Elixir, working with a very small team. Even in gaming space, I think Machine Zone is using Erlang for their Game of War architecture. And so how do you actually get this stuff to then run on the cloud? This used to be like a really painful process, at least for me. I'm really like a development type of guy. I like writing code, but I'm not really good at maintaining machines in the cloud. So I never liked that part. But nowadays, there's luckily enough, I think, a really good solution for that, namely containers and an orchestration of containers. So we actually run everything, all the game servers in Google's cloud on their hosted Kubernetes. And it really kind of turns the thing kind of upside down, that instead of us renting a machine from them and then maybe installing some software, we just tell Google Cloud that, okay, run 7 copies of this piece of software in a cluster somewhere, and then it kind of figures out by itself that, okay, 7 copies means that there needs to be 3 machines, and then it will actually deploy those 3 machines and install the software there, whatever requirements are otherwise needed. So it also puts them there, like all the log forwarding and so forth. And as a kind of repercussion of this, you also get like basically scaling for free. So you just tell the system that, okay, I need 1 more, so let's go up to 8 and then up to 9, and it will automatically figure out again, like that when you need new machines, it will auto provision them for you. Other benefits that we really got compared to at least our old way of doing things is that the deployments themselves are really fast nowadays. So 5 minutes from a commit that I can actually see the change live, and usually the update downtime is somewhere in the order of 10-15 seconds that the service is down for people. Also the Docker system, like because it basically is very self-contained. When you build a Docker container out of your server, it has all the dependencies that it needs from the system. So there's no more maintaining of these virtual machines, that making sure that everything has the same set of and same versions of applications and dependencies installed, but instead they all come in a one bag, so that it's easy to make sure that everything is kind of running the same thing. And also, because of the way how it operates, most of the failures that usually occur in a system like this, it can actually self-heal. So if a node goes down, it still knows that I'm supposed to be running 8 of these servers. It figures out, oh, but I don't have enough machines, so it will provision another machine, automatically install your servers there, and just keep running them. Obviously, you need to handle those kind of error situations to a degree yourself, but it really helps out a lot. So just to summarize, identify what you need to build yourself, do it, and then buy everything possible from somewhere else. It always is cheaper to buy than to reinvent the wheel. And try to focus as much of your time on developing the application and minimize the time you spend on operating a database or doing other craft work like that really doesn't add value to your players. And thank you. That's everything.
Great. Thank you very much. See, I'm old school. I remember when I was back in like '98, and we were basically, none of this stuff existed, and we were actually using laptop motherboards in order to make what was probably the first rack system when I was at British Telecom to run Quake games. And when you think about the journey we've come from since not that long ago, if you think about it, 98 is not that long ago, to where we are now, where, like you say, you've got these server farms which you can sit there and just spin up on demand, that you can define and self-heal. All of this stuff is incredibly important. And if you're not thinking about the server constraint in your game, what are you doing? You can't deliver services without, would you agree? You can't deliver service experiences without using that kind of technology.
Yeah, it is super tricky in the sense that obviously you have to do that beforehand. Otherwise, if you really get those players, you're going to be beating yourself over it that, oh, we can't scale, and then you basically lose the whole case. But also otherwise, like if you don't get those players, then you spend a whole lot of time just like kind of architecting and implementing it. So it's
yeah, and I think the layering, because actually the layering you showed is very similar to what we had in the old Wireplay days, in the old kind of dial-up modem days. It's not that dissimilar in terms of kind of core concept, but the actual kind of components inside that are so much profoundly different in terms of their stability and their structure. And like I said, the kinds of languages that you use can affect that too. And so I find it fascinating. We're kind of having the same conversation that we had when we talked about platforms that long ago, and yet it's becoming even more important. I mean, in some of the projects I'm using tech like GameSparks or Chili Connect or PlayFab, off-the-shelf tools, because I'm basically designing projects which are about what can I do within these constraints with these low budgets. But I love the fact that you were able to actually say, look, hang on, we'll use what we can, but these things we can't do without making it ourselves. How did you make that call of what to make and what not to make?
So basically, we actually had like a previous project that we had already built some of this technology for. So we kind of had a starting place there, and obviously it did affect somewhat when we were deciding on this project, like what should we build. So there were some things and ideas that would have been very, very difficult to kind of map onto that existing architecture, and we kind of had to discard those for that reason. And neither would they have been doable with kind of off-the-shelf tooling. I mean, obviously, if you can use off-the-shelf tooling, you really should go for it, because building this stuff it's still like man-years of effort.
Oh, it's non-trivial, isn't it?
It's non-trivial, yeah.
I mean, I'm no coder, but I've spent so much of my career working with server coders as well as game developer coders, and it is like bashing your head against a brick wall sometimes. Most of the time, it's often, in my experience, I don't know about yourself, it's a small delta. It's like this small difference between this will run smoothly if we build it ourselves versus this would be easier to implement if we change the way we work. And it's so difficult to make, I find it so difficult sometimes to make that call. And it generally comes down to who's the guy making it.
It is very true, and like I guess that's why making games is in part so very difficult. That it's not just the server and the design, but it's also the art and the design, and everything and the design, the graphics guys and graphics code and client code, and everything kind of needs to be coordinated somehow. That you try to figure out things that are smart to do with with the team that you have and with the skills that everybody in the team has and so forth. And it's really, really difficult navigating all of that, not just on the server side, but obviously also on there.
And I think that's a great way to end it. So thank you very much. Thank you, Patrick.
All right, thank you. Just as a last thing, I really want to plug my colleague, our creative director, will be giving a talk in 4C conference later this week about the more about the design and the product stuff of Trade Town. So if that interests you, do check out his talk. I'm sure it'll be interesting.
Great. Thank you very much.
All right, thank you.
Perfect. So